Hey, this is Jason with BigRep here. We are inside the number 43 hauler here at the Darlington race. Over the past year, we've been partnering with Legacy Motor Club, with NASCAR for motorsports, understanding the way that 3D printing is utilized. I'm joined by Steven Sander with Legacy Motor Club. Steven, thank you so much for taking the time to talk with us. Would you mind telling us a little bit about your role at Legacy Motor Club?
Sure. So I'm the director of Aerodynamics at Legacy Motor Club. So we've been racing the Next Gen cars since 2022. This is a huge change from what we used to operate as. It used to be sheet metal, wielding it out to whatever shapes you want, heavy fabricating, lots of metal related parts. So there's a much tighter box in terms of the design freedom with the car. There's a number of components you can still design, but with how tight of a box it is, it's really by design, is really to help encourage parity within the sport. So the way that we can set ourselves apart from our opponents that we're competing with is just how well we execute. So being able to build a high quality car twice within every single weekend for the 42 and the 43, sometimes the 84, and do that week after week so that our race teams, when they show up here, they know exactly what kind of car they have, that they can hit their balance, hit their travels, and just give them a shot at competing.
That's something I know we've talked about offline, just how tight of a timeline you have in order to make and get the cars ready. So can you give us a little bit of an insight into what that timeline looks like for getting a car prepped?
Sure. So in a perfect world for us, it's a 5-week turnaround from when the chassis shows up as your center section, front clip, rear clip, start assembling the underfloor, then it gets the body panels assembled. Each of those is about a week process, and then we go through a full assembly, and then we go back to the hoist to set our underfloor, back to the teams to then be able to put in their setup and all their final items. For us, it's usually more like 4 weeks. So 4 weeks is a pretty typical turnaround from when you take raw components and send that car to the track.
So it's building a full car within 4 weeks, and there's really very little time for error in a sense within that time frame, right?
Yeah, I mean, we only had one off week this season, so it's 4 weeks, but then you also have 3 other cars that are within that cycle. So there's a lot of moving parts, and everything just has to move seamlessly from department to department so that we're all ready to do our job in a timely manner.
I think that translates a lot to a lot of the customers that we work with, maybe not in motorsports, but in just general manufacturing or production, who also have deadlines to meet, also are trying to get parts fabricated in time for meeting either their prototyping deadlines or even keeping their manufacturing lines working too, right? One thing I'd love to hear, obviously, we've been working together for a while, but can you tell us what machines you guys are using, BigRep machines you're using, and maybe what are some of the key components that you're using maybe from a production perspective?
So we have 2 Studio G2s that we're operating pretty much 24/7 at our shop. Key components that we're making, I mean, all types of templates and fixtures, because again, I go back to our ability to execute consistently week in, week out. So we use this heavily to make sure that we're getting our cars to look the same as what we're intending. There's a number of parts that go on the car. So we have nose ducts, so the brake ducts for your front brakes. We print those. Doesn't really make sense to make those out of carbon when there's a good chance you're going to take front end damage within a race. So it's pretty much a one-time use part. So 3D printing makes perfect sense for that. We have a gear cooler plenum in the back, which is a very large component. So something you can't just print on a small hobbyist printer, that you need something industrial that's robust and large in size to get you really accurate dimension control and be able to print within a large volume.
That's great. Some of the materials too. Can you tell us what materials you guys are using?
Actually exclusively been using BigRep materials. I know we have the freedom to go use other materials, which I love having that freedom, but it's just not been necessary for us. Every issue that we've come up with, there's a solution right there. So we've used TPU for being able to do like little gaskets so that we can stretch them over parts of the chassis that need to have consistent sealing. We've done HI-TEMP CF for regions where we need the parts to be strong, but also really resilient to high temp situations. And then Pro HT we've been using very heavily. So when we just need nice looking parts where strength needs to be there, but not too critical, and the temperature environment's not too critical. We recently started actually playing around with high temp, and we're really impressed with that material. So there's so many options for us to be working with. One I forgot to mention right there is BVOH. So we have a water soluble support, which allows us to do very complex geometry and not really have to fight with getting support off the part, that we can just wash it off. So it's really opened up a lot of possibilities for us.
That's awesome. The benefit too of that BVOH. I know there are other materials out there that can be soluble, but typically take like chemicals that you would need to. So just from like a safety perspective, we're getting anybody to kind of chip into to be able to wash those off is probably pretty handy as well, I would imagine.
Oh, absolutely. And the nice thing with BVOH is that we can actually break most of it off really easily without damaging the part. So you're not having to wash out everything. So if you got some little tight crevices that's kind of hard to get it off there, you can wash that off. But 90% of the time we can just break it all off, and then we don't even have to deal with washing it.
So yeah, like we mentioned, Stephen, we've been working together for just over a year, roughly. Can you tell us a little bit about what it was like before you had the 3D printing in-house, before BigRep was involved?
The thing that really highlighted the need to me that we needed to find a partner with this capability was, I talked a little bit about our gear cooler plenum. Well, we iterate the design of that very frequently, and being able to print that, you can't do that on the small hobbyist printers that we had. So for the situation we were in, we can either go to another team and purchase a carbon part, which is very expensive, or we can outsource it to a 3D print shop that could produce the part for us and send it to us. The difficulty with dealing with that, which is what we had to do last year, was the big thing was lead time, to be honest. So if I have a new design that I want to get on the car, typical lead time from when I send out a design to when I receive a part was about 2 weeks. 2 weeks is a lifetime within NASCAR. Like within 2 weeks, we could have a new design, and that part is now obsolete by the time it shows up. It was not cheap outsourcing printing. So the biggest thing that was frustrating for me is the shop that I was dealing with, I didn't have any support as to what can I even do? Like, what type of material should I be looking at? How should I have this part oriented to be able to slice it, which I wasn't handling, they were handling it. But like, how thin can I make these walls? What type of, infill should I have?
Right.
Because weight is obviously always a concern for us, especially for this component, which is really high up in the back of the car. We want that to be as light as possible. So for us, just needing a part in hand, we had to play it really safe. Do very thick wall thickness, just immediately went to a carbon filled ABS materials, just said this should work. Parts that we received were probably twice as heavy as the carbon parts that we were previously purchasing. So the thing that's been like so nice about this partnership is that, it allows us to play with things at our shop on our machines, but at the same time, we have support over at your guys' facility that we can stay in contact with your engineers, and we can send designs your way, get feedback. Oh, you should try it like this. Oh, hey, let me try this at BigRep. We're going to try slicing it, seeing if we can do this material, print it like this. And you guys will figure that out for us. And then just send us back G code and say, here, run this on your machine. It'll be flawless. And it's been great. So this component I was just telling you about, how I said it was twice as heavy as carbon. Well, as we've been iterating that design this year, we are now at the point that we can produce parts that are the same weight as the carbon part that we were receiving before.
Oh my gosh. Wow.
And the material cost for that, I think we're around like $56 a plenum as opposed to $2,000. So when we're trying to save weight within NASCAR and all motorsports in general, there's typically a cost associated with shedding weight. And we all have a dollar amount. We're willing to spend this much amount of dollars to get 1 pound out of the car. Additive manufacturing, and specifically 3D printing, is one of the very few applications where we can save weight, which then actually saves us money.
You get to check 2 boxes off at the same time.
It's very rare you get to do that. So we've been thrilled with being able to do that. We can constantly iterate our designs. We've been doing it nonstop this year. I think we're probably on the 5th iteration of what this design is, which is If we would have just committed to carbon parts, there's no way I can justify the tooling cost to do that 5 times within a season. Anything you work on in engineering, it's speed, money, quality. We get all 3 out of this.
Love it.
It's always said that you got to give up one of those, and we're not having to.
That's a great. I need to take a second for that.
Everybody in the shop's coming to me like, "Hey, that's cool. You got that. Can you do this part for us?" Like, yeah, sure, why not? But again, I'm still going to keep going back to just the quality of our cars, of being able to make the fixtures and templates and everything we can just so that we can keep producing the same high quality car week in and week out. Being able to do that, and then really just prototyping parts where we don't have to go machine out a large metal piece. If we're going to end up having to do that eventually, we can just prototype it and be able to check our dimensions and tolerances that way. So I think that's where I see it going within the sport. But again, it's hard to tell because ideas come my way every single day from our shop of what we can do, and we're just implementing things that I never even thought were possible.